Hello everyone. So thanks for joining in on a weekend evening. So that's a great effort to put something to learn something new. Today we are going to see something around how to get started with Azure Machine Learning. So I've been hearing a lot of conversations, especially from students that there is a lot of buzz around Gen AI, but I'm a complete newbie. Where should I really get started with artificial intelligence? So, is it really that tough to first learn what is machine learning, then try to implement in cloud? So, I think what I decided is that, let me try to take one opportunity to answer all your questions around that and to make it very easy for you to know what's really happening in Azure machine learning and how could you can get started. And I'm going to bust one simple myth at the end of this session. So if you stay tuned till the end, you'll be able to crack what's happening around. So I think I've been hearing a lot of comments around and questions around, will I get charged if I use Azure machine learning, if I use services in Azure which is related to machine learning, if I spun up something? Yes, of course you do. So the smart way is to how to do it in free trials or free version so that you can learn a lot of things, and when it's right for industry you can try implementing it. And today I'm going to take you through very basic terminologies that exist in this ecosystem, and I'm going to show two ways today and how you can um, get the data set to the cloud and do some transformations and train your model on top of it. And the best part is today I'm going to do it in a complete no code way, which means uh, whoever it is who is coming to Azure today or tuning into this session, whether you are an expert or a complete beginner or you don't know what is even machine learning, I think today you'll be, by end of this session, you will be able to say that, I know how to work with data in cloud and do some machine learning operations on top of it. So that's going to be my objective today, and we'll get started. So what I do, thanks Rohit for a wonderful intro, but just a little bit more what I do around here is that, So I'm working as a VP of product at Nextem. So Nextem is a brain computer interfacing startup which develops hardware and software for your brain. I know that sounds complicated, but it's like we are creating a device that we will put on your head and that tells you what you think. Sounds crazy and interesting, right? But yeah, on the flip side of it, it's widely used in research and neuroscience, and that's where we are enabling a lot of people over there. And just a couple of months or in a year time, it won't be really crazy to know that you can control your light bulbs and your smart bulbs in your home with just your thoughts, or maybe just put on your song on Spotify with just your thoughts. So that's what we are also building. So stay tuned to that, and you can find more info about what I do in my LinkedIn. And yeah, I've been associated with communities for a very long time since my college days. Started as a an enthusiastic community person who dropped into most of the meetups to know what's happening around, and slowly, thanks for the so many mentors and people I came across through this journey who helped me to reach this spot where I'm actually talking in front of you guys. So yeah, a lot of community stuff, and I've been leading Azure developer community since 2021, since its inception. And it's a great honor that we got Azure developer community got mentioned in the keynote session at MS AI to 2024, and also one thing is that I got to even meet Satya Nadella in person among a couple of other folks who were winners of AI Odyssey Challenge. So yeah, pretty amazing stuff's been going on in this community space. If you're not joined it, please just go ahead and register, and you'll get what's happening around in the community, or head down to my LinkedIn profile where I keep on shooting out events that's happening around as well. So Guinness World Record holder, I have a lot of passions towards machine learning research and AI research. So published a lot of research papers around it, and went down to cloud to enhance my deployments and fine tunings around that. And a lot of got certified around the same space. And hackathons have been my time pass or hobby since my college days. And though I'm not that much active in hackathon eco space at the moment, I do get to judge few ideas then and there. And you can my Instagram or LinkedIn where I try to create some videos, short content videos. If you like it, tell me what should I talk next time, and I'll be happy to do a video on that. Besides all this stuff, from startup to community, yep, I do go around, play guitar, or if you're on Instagram, my personal Instagram, I'll spam you with Instagram reels if that's the case. So yeah, so that's what I do, and let's go to this is my it has all my handles. You can take a screenshot or a photo or just scan right away, and it will point to my social handles, and that's how you can get connected to me. And if you have any doubts or something, just go to my profile and shoot a question. I'll be happy to help you around. And yep, if you haven't joined developer communities, yep, feel free to do so. And we have been hosting a lot of events then and there. And stay tuned to this season of AI in YouTube as well. We have a lot of interesting and expert folks who are coming in to talk about what's happening around in AI space. So what's going to be today's talk? As I told, my aim is to get you guys enabled to start with machine learning in Azure and with no code. So again, even basic Python programming is not we are going to use today, but yeah, that would be quite helpful if you're going to the third way of doing it. And if you have a little bit of experience about machine learning, that would be cool. But if it's not, don't worry, that's not going to be a problem. And get started with Azure account. So I hope so. If you are a student, you get a $200 credit, if I'm not wrong, or be very careful around using pay-as-you-go subscription and make sure that you use cloud alerts and billing alerts so that you don't cross any limit. So we'll get started with the main agenda of today, which is what's Azure Machine Learning, what it does, and what should I know about it. So in this section, we will see around what all machine learning workflows does it exist, and when you do machine learning in a conventional way, like for example, if you're already into machine learning, I think one simple way that you do is you just go to your VS Code or your Jupyter Notebook, start writing your code, run it and test it, and so on. So, and what really happens when you go beyond a one-person project? So, which is like you work in a team for a research paper, or you're working in a company which has more than 10-15 people sharing the same data, code, and stuff. So that's where the complication really starts. And what all challenges does it really have, and how Azure is going to really make that easy for you guys as well as a organization or the team. And we will see a few terminologies and architectures which is regarding the Azure ML, which is quite necessary for you to know to make it quite easy for you to use stuff in there. So to understand what happens in while you do something, like while you wanted to learn how a data works and how you want to train a machine learning model on top of that data, there are a couple of steps you want to do. So briefly, that can be put under a couple of ways. So first thing is there is nothing going to be without the data. So data is more important, and I think we will start with where you want to really host the data. So you want to do it in local or you want to do it in cloud, and where you want to host it and what you're going to do. So once you have the data ready, and that's where you can't simply put it through machine learning model and expect it to learn how the data patterns work like. So yeah, that's pretty difficult, right? So imagine that you have a baby that you want to teach it how to speak something. So it requires a repeated way of telling something, and also make sure that you associate those words with actions, triggers, or something, so the baby tries to learn something out of it. So typically, I think that's a weirdest and closest analogy that I can put it at the moment, but yeah, still works. So data source is where you wherever you are hosting your data. So today we are going to use a very simple and a standard data set that's been around for a lot of years. That's a very standard project that you use for machine learning. Anyways, the ultimate aim for me today is not to teach you machine learning, but how to do machine learning on cloud. So yeah, better to get started with simple stuff. So next thing is, once your data is ready, you have to understand how the data works. You have to transform it. You have to clean the data. We will see a little bit in the upcoming slides or in upcoming workflows. Once you're ready that your data is good enough to put it through a machine learning model, that's when you start creating something called a training environment. So you have a machine learning model, and it might be written in C++, it might be written in Python, and even in Python, it might require you a couple of libraries to be installed. Whether it might be if you're using deep learning, you might be using PyTorch or TensorFlow or Keras or whatever it is. So there are a lot of frameworks and libraries that is associated with it, and which means when you want to train your model, you want those library dependencies to be existing in the same machine or the compute that you're being using. To help you with that, we can create a virtual environment or a separate an instance, a compute instance, or maybe you can create a Docker image and make sure that you install all the necessary libraries or necessary stuff for your machine learning model to be able to run in that environment. So that's what we call it, a training environment. And it's pretty much, if I wanted to put it in simple terms, it's nothing but your requirements.txt file if it's Python. So simple as that. So now you have your data and you have an environment where you could actually start training your machine learning model. So there is a machine learning model. So for that, you have to select a machine learning model. So how do you really select a machine learning model? It depends on a couple of factors. So it depends on what of your problem that you're trying to solve. Is it a classification problem? You're trying to solve whether it is 1, 2, 3, 4 or more. A selective, distinctive, limited number of outcomes. So that's classification. If that is infinite, that there is an infinite number of outcomes that could come. For example, it can be a whole number, which means or decimal number or whatever it is. So if I tell that 132 might be an answer for this, or it might be like 1246. So if there is a continuous value that is going to be the outcome that you're going to expect from the model, that's going to be regression. And these are called supervised learning. So we can talk about all these machine learning basics if you are not good, but for the context of this particular session, I'm still throwing out keywords so you can go back and refer and learn and come back and resume this video so it makes complete sense. So, there are different types of machine learning problems, and once you identify the problem, which is classification, regression, or clustering, and so, you try to choose a model which works best for you. So again, how do you do it? It's more like a trial and error method. Like you feel that, okay, this model, SVM really works for me or something like that. But again, you might be really wrong. And that's where the machine learning engineers try to deploy or select multiple models to see how the results vary. So let's assume that you have finalized and you're happy with one of the models and you prepare a training script. And what does it do? So now we have three entities. So we have a training environment, your data exists, you know what model to use. So you want a model to get trained on the data. So to instruct that, that's where you need to write a script. It can be a Python, it can be C++, or even shell commands if you're really interested to work on that. So you write a couple of pieces of lines of code that takes the model to be trained on the data. Simple as that. So once you trigger that particular script, your model gets trained, and for the model to use all the necessary libraries, this training environment still works best. So what happens after that? That you get a result that, okay, the model is able to classify 70% always correct. Like I can't say that that's not the right way to say it because there are false positive, true negatives, and four different stuff. So just for the sake of simplicity, I'm saying that the model is 70% accurate, and you're not happy with it. So what could I now change that could improve my results? Yeah, the first thing is I could go ahead and try out different parameters that the model has. For example, if you are going with SVM, you can change the alpha, or if you are going with even other models, you can see a lot of parameters which actually changes the model's uh, behavior. So you try to change the values for the model and see how it improves. For example, I'm changing few parameters, and for some reason it improves from 70 to 73%, which I'm still happy. Now I'm okay. Now it improves, but I'm still not happy. You go ahead and try it out with different models with different parameters, and once you reach a satisfaction level that yep, it does really work well. Maybe I'm achieving a 99%. It's not really true, but yeah, 80 to 90% of the accuracy. So if I'm really achieving it, yep, I'm good enough right now. So we finalize the model. Now what? So I think most of the college folks or people who have been working with data or trying to learn machine learning, obviously, like they think that the job is done when I'm able to train a machine learning model and see that the accuracy is done. But the real game starts after this. So when you go to an industry or any project or even a research environment, the whole purpose is to enable people or users or end consumers or whoever to be able to get the predictive analysis from the model. So how to do it? So you have a trained model. It can be like .pt dot if you're saying that in whatever it is. So you have a trained model, and now you have to put it in a training environment with a compute power, where I'm going to send the data and I'm going to receive the prediction. So again, the deployment environment really works, which most of it includes the same as the training environment with a couple of more or less necessary stuff. And you have a trained model and find a way or create a pipeline that could take the data or the data that we need to predict on top of it and pass it through the model and predict it. So how do you do it? You write a inference script to take that data and run it through the model, and you perform the prediction. So I think we spent a considerable good 10 minutes to understand how a complete machine learning stuff works. So I think right now everyone who is tuned on to the session or maybe in future, now everyone is in the same page how a machine learning workflows do. So now we're going to take a next step forward, that how am I actually going to take it to the cloud, and why should I really take this to the cloud? So now pretty much we know what really happens, but what are the challenges that I really encounter here? So let's imagine I was telling you that you have to try it with different models and different parameters. How do I keep track of the results? Let's imagine I have a training environment that I could reuse for my deployment. How could I create, reuse, and delete this environment? Of course, one might say that, bro, just use Git and maintain your versions. Yep, that works. But imagine that you're working in a scale that your code can be versioned. But what about the dependencies and the resources that you want to really maintain? And for example, you wanted to give access to data to very specific people inside a project. Uh, Probably you are working with the sensitive data. And people who are working in deployments really do not need to know how a model is trained, but rather they just want a trained model to be deployed. So how do you logically create and maintain these resources? And let's imagine we have trained 20 models and one of it works. So how do I able to figure out which model really worked better? And since we told that we are going to reiterate the training script again and again with different parameters and different models, if there is a way for me to automate it, for example, that, okay, I'm using SVM, I need to change the value of gamma from this to this range. Step is like go from 0.0001 to something like that. And if I do that, so which means you could automate it, which really makes much more efficiency. So these are what really happens when you take it to MLOps. So now we know what is machine learning, how the machine learning works, and we know how what are challenges if you don't really go for something that leverages machine learning operations, or if there is a service that you could leverage in the cloud. So, how could now start with Azure Machine Learning? So, what all terminologies do I really need to know? So, how to start with? You can do it in Azure portal. You can go there. You have Studio, which has UI based way of doing it, and you can code there as well. You have Machine Learning Designer, which is completely UI and less coding, and you have Azure CLI, which is if there are aliens who really love to work with training machine learning models through CLI, then you could use CLIs. But of course, CLIs are great tools for you to automate and do a lot of operations work. I'm not really saying that it's a broad one, but it's really not a good fit for who wants to experiment and try with Azure machine learning. And of course, everyone's favorite, Python is here. So we have Python SDK that you could use to run your compute loads in cloud. Simple as that. So now let's deep dive into what these architecture and terms mean. So on a broader level, if you are new to Azure itself, just go and create an account, and you will be able to see something called subscriptions. So subscriptions denote uh, what you're eligible to do within that complete Azure account. So, for example, if you're free, that means you have a limit to do something with it. And I'm using a pay as per you go. So every time I use a service or leverage something, I get billed for that. So you can logically separate services and workloads inside a subscription, and you could group these services into a group logically called a resource group. So you can associate multiple resource group within a subscription and so on. Let's quickly go and check how that looks like in the portal. So this is your Azure portal, and this is where the subscription, this is called a subscription. Be sure you go and change your machine learning and billing alerts. And resource groups represent how I want to logically do that. So I have a resource group called Azure Demo, which means that once this session is over, I'm going straight and deleting those resource groups and terminating all those resources. Yep, that's how you can do a lot of stuff very efficiently. So coming back to our presentation, so you know how an Azure hierarchy works. Now let's come to Azure Machine Learning and what really exists over there. So in Azure Machine Learning, we call something like workspace. So workspace encompasses everything. So, and what all it encompasses. So you have a lot of assets where it's called environment, where you can create, maintain, and reuse environments. And experiments is where you could associate some repeated activity under a logical name. And pipelines are something that you could associate steps of some process in a sequential or parallel way, and you could make it. You could actually make it in such a way that you could pass parameters to this pipeline to customize it whenever you want, and you can execute that. And most probably, you can associate that this execution ties to an experiment which is going to be run in an environment. And data sets is where, of course, pretty much self-explanatory, models and endpoints. Endpoints refer to the deployments that you will see over there. So we have two linked services, which is called data stores and compute targets, which denotes that where is the data being stored and where are your workloads going to be executed. So that's data stores and compute targets respectively. And managed resources includes instances and clusters. So Azure offers you a lot of varieties of compute that you could leverage, which depends on how much virtual compute I need and what's the pricing that associated with it, what is the storage I need for that. You could select according to what workload that you are going to be executing. So pretty much we are going to go with the demo. So I'm going to choose something which is going to hurt less for my bill. So which is typically, we'll see when it comes over there. And what all it's dependent on. So since you have Azure storage account, that's where you could leverage that to store your models, data, or any necessary outputs, logs, etc. like that. contain image registries where you try to it's a managed service which helps you to save images. So what I mean, it's not the image, it's Docker images that you could take and store. So which helps you with maintaining environments, or just pick the image and put it in a cluster and run over there. So it works. Key Vault, of course, for security and keys that you could generate, and application insights is where you try to see the logs and other stuff. So this is an overview of how the architecture and terms exist in Azure Machine Learning. And I think I'm pretty much it's okay to skip these slides because we have explained it. And I'll make sure that to drop this in my GitHub so you can go back and refer to these slides probably later. So we know that Workspace is a complete, which associate a lot of Azure resources and stuff. Experiment is like a named process which usually runs a script or a pipeline. And the run context is where what really went through that execution. So now let's go ahead and start training machine learning models. So as I told today, I'm going to help you with two ways to get started with Azure machine learning training of machine learning model in Azure, which is going to be a no code. So we are going to leverage two things. One is the Azure Machine Learning Designer, and the second is guess what it might be. It is nothing but your automated machine learning. So, if you have any doubts, I could love to take it at the whenever you are stuck or if you want to shoot any doubts. So, ways to train your model, you go ahead with designer, automated machine learning, or you do with the code developer way. That is, write your Python code and execute over there in the cloud. So, we have a couple of ways to do it, and you know how that works. So, let's start with the designer, the first way of doing it, and I like to go to Azure Machine Learning. So you can search over there in the search bar, or if it is there in this, just go ahead and click it. And I've already created it, but just create a new workspace. You know what a workspace is right now, right? So create it, and it asks a couple of details about the name and etc. Just give the details and start it. And once that is there, I could launch this particular workspace. So let me launch it. And it has a lot of stuff. So it includes notebooks where I could run the notebooks over here, automated machine learning designer, tracing, datas, jobs, pipelines, a lot of stuff. And you could still start with Gen AI right away with the demos and examples and notebooks that is already available. Yeah. Cool. Now, a few examples that is how you could start train and deploy a model very quick. That's the third way which we are going to do. So, which I'm going to leave it for you guys to go ahead and explore. So let's start with designer. So there are a lot of pre-built stuff like image classification using DesNet, binary classification, and so on. So we're going to build a very simple pipeline. So let's start it from scratch. So as I told today, my aim is not to teach you machine learning, but how to do machine learning in cloud. So I'm going to pick the easiest data set, which is very conventional, very easy, which is the Titanic data set. So if you guys haven't heard about it, it's nothing but it has information about the passengers and it has count about who survived and who didn't. Yeah, it looks a little dark, I know, but yeah, that's going to help us today to learn something new. So which is let me try to import the data first. So already it's there. Let me try to help you to do that again. So I'm going to put that as Titanic dataset. Okay, I already have that for demo. Should I? Okay. It shouldn't have any spaces, I suppose. I think now it should work. Yep, now it's good. And I'm going to upload from my files over here. So, yep. Click upload files, and I'm going to dataset. Yep, I have it. Cool. It's uploading next. It loads the data set and shows you. So it's our passenger ID, survived, P class, which is a passenger class, the name, the sex, age, and what is is IBP? What does it mean? Let's see that. Cool. So there are a couple of columns over here. So we're going to take one which is quite easy. So everything is pretty good for us. So I'm going to click next. And here is where like I could manage the schema. So for example, to make it much more easy for me to do machine learning today, of course, passenger ID does not have to do anything with who is going to survive or not. So let's remove that. Passenger class does, name doesn't really do, but gender really matters because it has a preference who gets to get on the lifeboats first, right? So yeah, of course, and age also matters. So the patch and stuff like that. Ticket ID really does not mean anything because we know how where and people are seated with the class and the patch and etc. And even how much I paid will not really help me to see if I survived or not. No, it's not going to work. And for now, to make it very easy, we're not going to touch strings today. So let me remove that as well. So we're going to do with a lot of integer stuff, which is going to be this one. But yeah, I'm going to help you with doing something with call the gender. So it's still string, and how am I going to make it easy for the machine learning to understand whether it is male or female? I'll help you to show that today. So, yep, I'm creating this particular data set and it's being created. So I'm going to use it today and use data and it comes over here. So now what I want to do is, as I told, I wanted to make those gender as zeros and ones, which is easy for my machine learning model to understand. So how I'm going to transfer, I'm going to do something called one hot encoding. So let me try find that. Let me check if it is there or yep. Let me go ahead and check if there is an operation for me to convert those strings into um, this one. So there are a lot of ways for you can do it. So then, yep. So yeah, obviously I think we can run a script by ourselves. So for simplicity, again, we can go ahead and use an algorithm today. So again, whatever works for our classification, because survived and not survived is only aim for us. So let me go to classification and see what all available models are there for me to use it. So let me do two class classification. Yeah, that sounds good. So I do that and I'm going to, okay, now I wanted to uh, transform this data and I need to train this model. So let me go with model training and I'm going to train a model. So this requires two things, which is a data set, which I'm going to connect over here, and I need to collect which algorithm it needs to train. Pretty simple, but it still requires me to do something, which is what what is the final value that I like to do. So so survived is the one which I really need to do that. So I'm going to save. And if I do click configure and submit, that's where the model training will start. This pipeline will start executing, which eventually takes you to that. So I'm going to show you, which I already trained, what really happened with that. So let me go to the pipelines and yeah. So I've already trained and cleaned some machine learning model in this one. So the model is pretty much trained. So you could go ahead and see the values, which tells you how well the this one. We can create an inference pipeline right away from here. So that's the first way to do it, which is pretty simple. You don't really do any coding and you're able to do a lot of stuff over here. So that's we have done with the first way of doing it. Let's go back to our presentation, which includes how to do it in the second way, which is imagine that it's still a very big hassle, right? I don't want to know how to, what sort of data transformation should I need to do with the data, or what should I do to select the best model with the best hyperparameter? There are a lot of questions. What if the system can do it for you, or if your machine learning is smart enough to do it, let it figure out by itself. And that sounds super cool, right? Yep, that's what automated machine learning works. So how does it automate work? So it selects the necessary columns that is required, and it goes ahead and selects best models among whatever it is, and it fine tunes the same model to achieve the maximum accuracy, and it gives you the best model that you could look for. So simplified way to tell what how automated machine learning works. But yeah, it is complex. It can go through hundreds of models to find you the best model, which you don't really have to do. So what's really different? So it this one you don't really need to have any programming knowledge. It's very easy to test hundreds of model in one go. It uses the best practices, and it's pretty fast. When to use automated machine learning? So this is one question. So I do get heard a lot that is automated machine learning really a curse for data scientists or machine learning person because it robs of their expertise. No, I will still not agree to it. The reason is that automated machine learning does a lot of help for you, but it does not really bring one thing to the table, which is the domain expertise, which is really required for you to help you to understand the data better, as well as fine tune the model better and get the right results. So that's when you have to really, really go ahead and choose your own conventional way. And if you want to do something which is a standard data sets with the standard process, and you want to achieve some quick results, quick, decent results, then automated machine learning is a very good choice. So how it works, I think it pretty much I have told you a couple of times. You take the data, you run it through multiple algorithm pipelines and see which works better, and you fine tune it. So now let's go ahead and use how automated machine learning works. So I'm going over here and I'm going to create a new automated machine learning, and I'm creating an experiment. So now we know what an experiment is, correct? Next. Yes. So I'm going to use the Titanic dataset, which we had developed. And what type of task are we doing? Yeah, you know what it is. But it also supports a lot of stuff. It uses computer vision, time series, and stuff like that. Then you select what's the target column. It survived pretty much, you know it. And you could use k-fold validation if it is you like it. For me, I like 5. And if you have a test data to benchmark it, you can upload it as well. So if you're new to machine learning, don't get scared by these stuff. You could just learn if you go around and figure it out. Then where do you really want to run this machine learning workloads? I wanted to run that in compute cluster, which is not there. I could run it serverless, which means I can define which virtual machine should I use it and what is it as well. So, and then click next and then submit. If I submit it right now, it would take a couple of hours to figure out the best data set, which I'm not really going to do, which we don't have time. So I've already created, okay, I already created for you guys. So, okay, let me check that. So the models which it had trained is, yeah, it got 86 the AUC is 86. Let's see how the accuracy were. So this was the best model. The ensemble represents a couple of models, pretty good, cool. And how the metrics look like, let's see. The accuracy is 82%, which is still good. But again, accuracy is not a really good metric for you to define classification. So let's go to F1. F1 still is 0.822, which is really good for this one. And the learning curve also seems pretty well. So I think it have done a pretty good job. So, and what I could do with this model, I could immediately deploy that or download it with just one click. So, what are the next step for me to actually deploy? So, you create a scoring script, or you could use leverage that, and then create a inference or deployment configuration, which compute you want to do it and whatever it is. And you can deploy that in either in your local compute or in Azure's compute instances, or you could go for Kubernetes services. So, I think that's the whole way you could get started with Azure Machine Learning right away. So, quick recap before we wind off this session. Okay, a quick recap is that, yep. So we know how an Azure, what is Azure and what all it has. We also saw about what all terminologies now it exists. So if anyone walks to you today and asks you what is an Azure workspace, you will be able to tell it by this. And you have learned two ways with no code how you could take a data set, register in our data store, and try to access it with Azure Designer, which is a no code way to do it. But of course, still, I explained a very simple example. So I like to ask you guys to go ahead and see what all does it exist and what all you like to see in the designer part and stuff like that, and do it. So explore more and figure out all the data transformations that you like to do, and then go ahead and also do it automated machine learning. It also tells you what all data transformations that it done it. So for example, um, it had ignored one column. It had used a mean imputer, which is like if there is a missing value, it computes mean. If it's a categorical value, it goes and does a label encoder. Yep, that's called a label encoder. I was searching for one hot. Let's go and see if it is there in the designer, if we had missed it. So that should be in transformations, I suppose. Yep, it should be there. Let's try it and figure it out because I'm quite curious around that front today. Cool. So we have SQL clean, convert to dataset, convert to indicator values. I think yes, pretty much that's what we were looking for. So instead of putting that to the dataset, I'm going to put that. No, you come over here. Let me delete that. Your data output should go to here. Um, so what is a categorical value, which is the gender, right? Yeah, and override false. It will eventually do it. Save and good to go. So now I'm going to put the resultant dataset to here, and good. We have done a pretty good job. So yeah, and the train model, you can put it for inference. Again, another conference. So this is how you do transformations as well, which I slightly missed in the this one, which I could really not find the exact component which I want to put it. But anyways, we have figured it out. Pretty good job for myself, I suppose. And which includes that you can now know how to do it in designer way, and you know how to do that in the automated machine learning way as well. So you could go ahead and see which works best. You could set the maximum time it could train upon, like it has done a lot of trainings. Of course, there is an incur of cost as well. Be mindful for that, which I keep on repeating. So the whole session really took us for 54 minutes for me to find the best job, which is like in a comparative way. If I'm going to do it and manually, that's going to take me at least hours or days for suppose to run all these models and figure it out. I not really know that much models by chance, so it's a very time saving stuff as well as, but of course a little bit expensive on the other side. So today we have learned a lot of new stuff. If you are a newbie to this, and which pretty much explains us what was our context at the end of this one. So we were able to do the data source training, selecting the machine learning model, training script that it's done by Azure itself, and also we have got uh, hyperparameter tuning and a lot of other stuff. So we have learned a pretty good deal about how to get started with machine learning if you're a beginner, and go ahead and train your machine learning models in cloud with your own use case. So pretty much you have done the job over here, and you could connect with me over by scanning this QR code, which leads to my social handles, or you could find me at Meet Vivek Raja, which takes me to the your LinkedIn as well as my Instagram. So stay connected, and I'll be happy to help if you are going and exploring it for the Azure Machine Learning. So thank you for staying in for today's session. I think 45 minutes, it's a pretty good wrap around how to get immediately get started, and I think we have done a pretty good job.